Alright, so I'm really bored at home during this quarantine. After a busy day of sleeping until noon and procrastinating my homework as much as I could, I have nothing to do. I've resorted to playing with a tennis ball to pass the time. I forgot my physics. To explain gravitational potential energy, I'll use this tennis ball. Let's say I hold this ball out in front of me and I'll let go. I'm sure you can guess what will happen. The ball will just fall out of my hands to the ground. Unless you've been living under a rock, you'll know this is because of gravity. As long as you're within the Earth's atmosphere, gravity will have an effect on you and everything around you. It's a constant force, always pushing downwards, making sure that we do not float off into space. Let's go back for a second to just before the ball is dropped. The ball is above the ground, suspended there by the palm of my hand. It could potentially fall if my hand were to let go, but until then, it sits there with only the potential of falling. I think that you can see where I'm going with this. Gravitational potential energy, GPE for short, is the energy stored inside of an object based on its height above the ground. Because the ball is suspended above the ground, gravity now has the ability to make it fall downwards. The ball now has gravitational potential energy. It's not like gravity was not pushing down on the tennis ball beforehand. Gravity is constantly pushing downwards on every object. It's a constant. If the ground beneath the tennis ball was to magically disappear, the ball would drop until it reaches the bottom of this figurative void the scenario has created. Because of this, we can rule that gravitational potential energy is dependent on height, correct? Think about it. Before the ball was lifted into the air, it was sitting on the ground. You could say that it has a height of 0. It wasn't until I lifted the ball into the air for it to gain potential energy. Another thing coming into play is the mass of the object. It's difficult to express this with a mere tennis ball that weighs only 2 ounces. Imagine that I had the strength to lift a car the same height off the ground as the tennis ball. The height would be the same in both scenarios, but the mass of each object would be significantly different. Let's compare these two scenarios. A car is hanging in the air with the same height as a tennis ball. Which would have the greater gravitational potential energy? It doesn't take a physicist to know that the car would have a greater potential energy. This is because the mass of the car, another variable gravitational potential energy, is something it depends on. By now, we know that gravitational potential energy is dependent on 2 things, height and mass. The last variable, which should be obvious, is gravitational field strength, or just gravity. Depending on what gravitational field you're in, there's a certain amount of force pushing everything downwards. I do most of my experiments on Earth, which has a gravitational field strength of 9.8 newtons per kilograms. Remember that number because it's important. We can turn these values into a formula. As far as we know, everything that attributes to gravitational potential energy is height, mass, and gravity. We can take that and turn it into the equation. Gravitational potential energy equals mass multiplied by gravity multiplied by height. GPE is measured in joules. Mass is measured in kilograms. Gravity is measured in newtons per kilograms. As long as you are on Earth, it will always be 9.8 newtons per kilograms. And height is measured in meters. Let's take our formula and calculate gravitational potential energy with an example. Let's say an anvil that weighs 200 kilograms is sitting on top of a trapdoor 100 meters above the ground. Let's say that an anvil that weighs 200 kilograms is sitting on top of a trapdoor 10 meters above the ground. What is the gravitational potential energy of this anvil? To find this, all we need to do is plug each value into our gravitational potential energy formula. To find gravitational potential energy, we find the product of 200 kilograms multiplied by 10 meters by 9.8 newtons per kilograms. This will give us a gravitational potential energy of 19,600 joules. At that height, the anvil has a gravitational potential energy of 19,600 joules. Let's say we raise the anvil to a trapdoor 10 meters higher than the previous one. The anvil is now 20 meters above the ground. Again, we can use the gravitational potential energy formula to plug in each value. If we find the product of 200 kilograms multiplied by 20 meters multiplied by 9.8 newtons per kilograms, we'll find that the object at the new height has a gravitational potential energy of 39,200 joules. By raising the height of the anvil, the gravitational potential energy increased. This tells us that the gravitational potential energy of an object is directly dependent on its height above the ground. If it's raised higher above the ground, the gravitational potential energy increases, and vice versa. The same is true when it comes to the object's mass. Let's say we strap another 200 kilogram anvil to the original one and place it on top of the 10-meter trapdoor. Before, with a single anvil, the gravitational potential energy was 19,600 joules. What will change with a mass of 400 kilograms? Using the equation, we can find that the product of 400 kilograms multiplied by the height of 10 meters and the force of gravity, 9.8 newtons per 9.8 newtons per kilogram, we'll find that the gravitational potential energy of these two anvils to be 39,200 joules. Clearly, the object's gravitational potential energy is also directly dependent on its mass. By doubling the mass, the gravitational potential energy of an object doubled without changing its height above the ground.